This is Chapter 5, Lesson 2, Geometric Proof. So blank blank is the process of making a conjecture after observing several examples. So in those first two blanks, you're going to write inductive reasoning. So inductive reasoning is the process of making a conjecture after observing several examples. Unlike inductive reasoning, blank blank uses facts, rules, definitions, or laws to make conjectures from given situations. In those two blanks, you're going to write deductive reasoning. Okay. So inductive, you use a process. Deductive, you use facts, rules, and laws. Okay. A blank is a logical argument where each statement is justified by a reason. So a proof is a logical argument where each statement is justified by a reason. So you have to have a reason for it. Okay. You can't just state something and not give a reason. A blank blank, also called a blank blank, involves writing a paragraph to explain why a conjecture is true. So in those blanks, a paragraph proof, also called an informal proof, involves writing a paragraph to explain why a conjecture is true. So you're giving me reasons and why they're true. Okay. So let's look at example number 1. Example number 1. The diamondback rattlesnake has a diamond pattern on its back. An enlargement of the skin is shown. If measure 1 equals the measure of angle 4, write a paragraph proof to show that measure of angle 2 equals the measure of angle 3. Okay. So here's 1. Here's 4. I want to know that 2 is equal to 3. Okay. So I'm given the information measure 1 is equal to the measure of angle 4, and I want to prove that measure 2 equals the measure of angle 3. So measure 1 equals measure of angle 2 because they're vertical angles. Okay, so measure 1 equals measure 2 because they're vertical angles. Since measure 1 equals measure 4, measure 2 equals measure 4. Remember, because we said measure 2 was the same thing as 1. By substitution, measure 4 equals measure 3 because they are vertical angles. Since measure 2 equals measure 4, then measure 2 equals measure 3, also by substitution. Therefore, measure of angle 2 equals the measure of angle 3. Okay. So basically, we used information that we knew. We know about vertical angles, and we used the information they were given in order to figure out and prove that something else was true. All right, so this yellow foldable on the next page talks about the proof process. So step 1, okay. I list the given information, right? List the given information or what you know is possible. Draw a diagram to illustrate this information. So I take what's given, then I move on to step 2. Step 2 says state what is to be proven. So that's my hypothesis. Step 3, create a deductive argument by forming a logical chain of statements linking the given information to what you are trying to prove. Okay, so that's the statements and the reasons. Step 4, justify each statement with a reason. That's very, very important. You have to justify what you do. Reasons include definitions, algebraic properties, and theorems. Then finally, step 5 is state what it is you have proven. Okay, so that's the conclusion. Okay. On page 123, I have my orange foldable, which talks about same side interior angles. So this gives examples, shows same side interior angles, okay? So for example, same side interior angles are interior angles on the same side of the transversal, okay? So same side interior angles are supplementary. Remember, supplementary means they add up to 180 degrees. So I have 60 and 3x. So if I add these together, 60 plus 3x equals 180 degrees, because they're supplementary. I can subtract 60 from both sides. I have 3x equals 120, and then I divide that by 3, so x equals 40. Okay. I have corresponding angles. So corresponding angles have corresponding positions relative to the parallel lines. Okay, so remember, parallel lines, they're on the same side, they're corresponding. Corresponding angles are congruent, so that means they're the same. So this means 63 equals 2x plus 1. Subtract 1. I have 62 equals 2x. I divide by 2. So x equals 31 degrees. Okay. I also have alternate interior angles. So alternate interior angles are non-adjacent angles that lie between the lines on opposite sides of the transversal. So there's the example. So alternate interior angles are congruent, which means they're the same. So that means 139 equals 3x. I can divide by 3. X equals 4. .3 repeating. Okay. And then I have alternate exterior angles. Remember, those are on the outside. Okay. So alternate exterior angles are non-adjacent angles that lie outside the lines on opposite sides of the transversal. So alternate exterior angles are congruent as well. So 101 equals 2x plus 1. Subtract 1 from both sides, I get 100 equals 2x. Divide by 2. X equals 50. Okay, so those are examples of those 4 types of angles. All right. So continue on with geometric proof. It says a blank blank or blank blank contains statements and reasons organized in 2 columns. So a 2-column proof or formal proof contains statements and reasons organized in 2 columns. Once a statement or conjecture has been proven, it is called a blank. Now you're going to write theorem. Okay. And it can be used as a reason to justify statements in other proofs. So let's look at example number 2. So example number 2 says write a 2-column proof to show that if two angles are vertical angles, then they have the same measure. Okay. So I'm given lines M and N intersect. Angle 1 and angle 3 are vertical angles. I want to prove measure of angle 1 equals the measure of angle 3. Okay. So you can see right there. There's my drawing. So M and N intersect. And 1 and 3 are vertical angles. And I want to prove that they're equal to each other. Okay? So, I'm going to go ahead and start with my proof. So, it says statements and reasons. Okay? So, I basically state something and then I provide a reason for it. So, the first thing I say is lines M and N intersect. Angle 1 and angle 3 are vertical angles. That's given. Okay? They already told me that. Angle 1 and angle 2 are a linear pair, and angle 3 and angle 2 are a linear pair. Okay, so that's the definition of a linear pair. In letter C, measure of angle 1 plus the measure of angle 2 equals 180 degrees, and measure of angle 3 plus measure of angle 2 equals 180 degrees, because that's the definition of a supplementary angle. Measure 1 plus measure 2 equals measure 3 plus measure 2. So that's substitution. They both equal 180 degrees, so I can substitute them and set them equal to each other. So measure 1 equals measure 3 by the subtraction property of equality. Okay? So I subtracted the measure of 2 from both sides. When I do that, it cancels it out. So measure 1 has to be measure of angle 3. Okay? So, there are 2 try it out problems. I want you to go ahead, pause the video, and try it out. And when you're done, we'll go over the answers together. So, now that you've had a chance to work on the try it problems, let's go over the answers together. So, letter A says refer to the diagram shown. AR, so AR equals CR and DR equals BR. Write a paragraph proof to show that AR plus DR, so AR plus DR equals CR plus BR. Okay? So, what I'm given, AR equals blank and DR equals blank. So AR equals CR and DR equals BR. That's given to us. I want to prove blank equals CR plus BR. I want to prove AR plus DR equals CR plus BR. Okay. So my proof, you know that AR equals CR and DR equals BR. Okay. AR, okay, so that is given to us, right? So AR plus DR equals CR plus DR by the blank property, so by the addition property. Property of equality. Okay. So basically all I did was I just rearranged stuff. So AR plus DR equals CR plus BR by blank. Put in substitution. Okay. So AR equals CR and DR equals BR. That's what I wanted to prove. AR plus DR equals CR plus DR, right? Because we know BR is equal to DR. So I basically just substituted that in. So that's by the addition property of equality. Okay. And then so AR plus DR has to equal CR plus BR. Because remember, BR and DR are the same thing, so that's the substitution. Okay. Letter B. The statements for a 2-column proof to show that if measure of angle Y equals measure of angle Z, then X equals 100 are given below. Complete the proof by providing the reasons. So, there's my two angles. It says angle Y is 2x minus 90, and angle Z is x plus 10. Okay, so here's my statements. The measure of angle Y equals the measure of angle Z. Measure of angle Y equals 2x minus 90. Measure of angle Z equals x plus 10. Those are given to us. Okay. So, since that's given to us, I can set 2x minus 90 equal to x plus 10. And that's by substitution. Okay, so by substitution, x minus 90 equals 10, so I subtracted x from both sides. That's the subtraction property Okay, so subtraction property of equality. Okay. And then letter D, x equals 100. I added 90 to both sides, so that's the addition property of equality. Okay, so this is the information I was given. I substituted some of that information in. I subtracted x from both sides, and then I added 90 to both sides. And that is the end of lesson 2.